Hi guys, Assalamualaikum. We meet again. This is the very first tutorial video. We call it as tutorial 01. So for today's tutorial, we are going to cover on chapter 2, tutorial for chapter 2. And what I did remember is in the classroom we have already covered question number 1 and number 2. So for today we are going to cover on question number 3 until question number 8 for part A. Tutorial 2 part A. So let us look at the question number 3. A piston cylinder device with volume of 1 meter cube contains 3 kg of water and water vapor mixture in equilibrium at pressure of 500 kilopascal. Determine A, the temperature of the mixture, B, the volume and mass of water, C, the volume and mass of water. Okay guys, if you look at this question, it is clearly stated that in the piston cylinder, it is saturated mixture, isn't it? Because we have in the question a water vapor mixture, it is stated there. So for question A, it is easy to determine the temperature of the mixture because of what? The phase is saturated mixture. So once it is saturated mixture, so we just find the temperature from table A5. Okay, so because of this is saturated, so we just take T is equal to T saturated, which is 151.8 degrees C. Okay, it is very easy. Alright, now question B. We need to find the volume and the mass of water. So what we have in the question is we have V, 1 meter cube, and the mass 3 kg. But both of this info is for mixture, right? It is for mixture. So in order to find the volume for water or liquid, water in liquid form, and also mass in liquid form, so we need to find another way. Alright, so we look here. From this V and also M, we can find the V mixture, the specific volume for mixture, which is V over M, 1 meter cube over 3 kg. It is 0.3333 meter cube per kg. Alright, now we know already the V mixture, the specific volume for mixture. Okay, in order to find V and also M, I think we can start with M because of what? We know one equation which is quality. When we talk about saturated mixture, it should have something that we need to do with X, right? Which is quality. Quality. So the quality, the equation for quality is M vapor over M total. So the M total is actually the M mixture here. So the M total we have 3 kg. So in order to find the mass vapor, we need to find first the quality. So how to find the quality? Okay, we know that this is saturated mixture, and the other equation that we need to use is V is equal to VF plus X VFG. Okay, so from this equation we can find X. We can find X through V mix minus VF over VFG. It is equal to 0.3333 minus 0.001093 over the VFG is equal to VG minus VF, right? So we get 0.3737. So the X is equal to 0.3737 0.8889. Alright, now we already have the X. In question B, we need to find the M liquid, right? The M liquid. So by using X equation, we know that it is equal to M vapor per M total. And you should remember that 1 minus X is equal to M liquid over M total. So we know already the X, M total, we have 3 kilogram, so we can get M liquid is equal to 1 minus 0.8889 multiplied with 3 kg. So we will get 0.333 kg. So this is M for liquid. For V liquid, how to find is we can use this M liquid. Okay, M liquid. But in a mixture, alright, the total volume, specific volume, if it is liquid, we should refer to VF, right? VF. And because of we know already the partition of liquid in this mixture through this M, through the mass, so we can use this M in order to find the V liquid, right? So VF just now we find is 0.001093 multiplied with 0.333 kg. So we will get 0.000369. Thank you. So that's how we get the M liquid and also V liquid, right? So this one is question B. And for question C, we need to find the V for vapor and also M for vapor. Okay, we still use this equation, which is X is equal to M vapor over M total. So from this equation, we know already the X is 0.8889. So by using this X and also M total, which is 3 kg, so we will get the M vapor. So M vapor is equal to 0.8889 multiplied with 3 kg. So we will get 2.667 kg. Okay, so same goes to V liquid, V vapor, sorry, V vapor. We can use the M vapor and we just multiply with the VG. If just now we want to find the V for liquid, we use a VF, but for V vapor, we want to find the V vapor, we just use the VG. Okay, so by using M vapor just now, 2.667, we multiply with 0.3748. So you will get 0.9496. That is how we solve question number 3. Next, question number 4. A piston cylinder device initially contains 50 liters of liquid water at 40 degrees C and 200 kilopascal. Heat is transferred to the water at constant pressure until the entire liquid is vaporized. Determine the mass, final temperature, and total enthalpy change of water and show the process on TV diagram with respect to saturation line. In a piston cylinder device, it contains 5 liters of water and the temperature is 40 degrees C. The pressure is 200 kilopascal. Alright, so if you look at the question, it is mentioned that it is no movement because of the pressure is constant pressure. So first we need to find the mass. Okay, the mass. Okay, we should find the mass. I always remind you that whatever it is, whatever question that you get, you need to find first the phase. Whatever it is, we need to find first the phase. Okay, even though it says liquid water, so we have to verify either it is compressed liquid or not. Okay, so we look here, we find at 40 degrees C, and we look at the 200 kilopascal in table A4. In table A4, you look T at 40 degrees C, and pressure is 200 kilopascal. And after we have confirmed from table A4, we found that this P is higher than P saturated. So according to the phase condition, when P is higher than P saturated, the phase is compressed liquid. Yes, it is compressed liquid. Okay, so mass. We know that the piston is not moving, so it means that the mass will be equal. In any question, right, if the material comes in one amount of mass, so it means that until the end of the process or state, so the mass is still equal, is still similar, right? So in order to find mass, we know the volume, right? And also we know it is the compressed liquid. It is a compressed liquid. How to find? We need to use this equation. V is equal to V over M. So we rearrange M is equal to V over V. So the capital letter of V is the volume, small letter of V is specific volume. Okay, in order to find M, we use this equation. The V volume is given here, 5 liter, or is 0.05 meter cube over this V. So where can you find this V? Okay, look back here. This is compressed liquid at pressure 200 kilopascal. When we look at a table A7, which is compressed liquid table, we cannot find because of the pressure is lower than the minimum pressure available in that table. So we need to go back to saturated table. So we refer at a temperature 40 degrees C, and we can find V there. So there are two V at table A4. We can find the VF, so VG. So which one should we choose? Because of this is compressed liquid, so we need to find VF. We need to use VF. So V here is VF. It's equal to 0.05 meter cube over VF is 0.001008. Okay, so this V is VF at 40 degrees C at table A4. Okay, so you will get 42.61 kg. Okay, next question B. We need to find the final temperature. Okay, means T2. We need to find the T2. So we look back at state number 2. It says the entire liquid is vaporized. It means that the phase is saturated vapor. When it says liquid is vaporized, so it means that the phase is already saturated vapor. And we have another info, which is it is constant pressure. So pressure at state 2 is 200 kilopascal. Okay, so in order to find the T2, we need to find first the phase of the water at state 2, but we already know the phase is saturated vapor. So you just go through the table A5. It is saturated vapor, right? So just go through the saturated table, which is table A5, because we have pressure here. So you check at pressure 200 kilopascal in table A5. So you'll find the T2 is equal T saturated. We just take the T saturated because of it is saturated. Okay, the water is saturated, so you just take 120.21 degrees C. So this is the T2. Okay, next C. Question C, we need to find the enthalpy, the total enthalpy change, which is theta H. It is equal to mH2 minus H1. But which H2 and which H1 should we find? Okay, we look back. So the H2, we need to find the H2 at 200 kilopascal at table A5. This is saturated vapor, right? And A5 is saturated table. So from this table, we can find HF and also HG. So which one should we choose? Because of it is saturated vapor, we need to use the HG. So H2 here is HG at 200 kilopascal. How about H1? So H1, we look back here. This is compressed liquid and this is the state 1. So H1, we should find from the table A4 as well. We can find H, F and also HG, and which one should we choose? Because of this is compressed liquid, so we need to choose the HF. So it is HF at 40 degrees C. Okay, so this one is table A5 and this one is table A4. So once you get it, the M just now we already find at question A. So M is 49.61 and the Hg at table A5 at 200 kilopascal is 2706.3 minus 167.53. So you will get 125,943 kilojoule. How you get it? Okay, next we need to show the process in TV diagram. This is T, this is V diagram with respect to saturation line. So this is saturation line. Okay, so we know that from compressed liquid, at state 1, it changed to saturated vapor at state 2, right? Compressed liquid. So where's the region for compressed liquid? It's right here. So it is somewhere here. So the saturated vapor for state 2, the saturated vapor should be the right hand side of the saturation line. Okay, so it is somewhere on the line, right? So if let's say it is here, but in order to reach from point 1 to point 2, which is state 1 to state 2, you cannot go directly like that, like this. You cannot, okay, because of what? We have this saturation line, so we will come like this. Okay, so the water will be totally vaporized, so it will become the saturated vapor. So it need to reach first the saturated temperature, so after that it will reach the saturated vapor here. So that one is question number 4. Next, question number 5. A piston cylinder device contains of 0.6 kg of steam at 200 degrees C and 0.5 megapascal. Steam is cooled at constant pressure until 1/2 of the mass condense. A. Show the process on TV diagram with respect to saturation line. B. Find the final temperature. C. Determine the change in volume. Alright, so we have a piston cylinder contains 0.6 kg of steam at 200 degrees C and 0.5 megapascal. So it mentioned that steam is cooled and some of the mass is condensed. So it says that 1/2 of the mass condensed means that 1/2 of the mass of the steam is become liquid, right? So first we need to show in the TV diagram. Okay, in a TV diagram. This is TV diagram. Okay, this is saturation line. Okay, it says that it is steam. So steam basically it is superheated. Okay, it is superheated vapor. So where is superheated region? Is right here. So it is somewhere here. Right. So it says that some of the mass, 1/2 of the mass is condensed. So it means that now at state 2, it will become a mixture because of 1/2 is mass and 1/2 is vapor and 1/2 is liquid. So it is somewhere here. Right, it will become like this. Okay. So this is how you show in TV diagram. You should not directly link from point 1 to point 2, just directly link like that. So you need to go through this. Because of what? From superheated vapor, it will drop to the saturation line first. Okay, in the saturation line, there will be saturated mixture here. So this is how we show in TV diagram. Right. Question B, we need to find the final temperature, which is temperature at state 2. So in state 2, you are not given with any info except it is condensed 1/2 of the mass. So 1/2 is liquid. Okay, basically when the condensate it is in liquid form. So another 1/2 is vapor. So at one time when we have both liquid and also vapor, so we call it as saturated mixture. So at state 2, you are not given with any info except this and also constant pressure. So it means that P1 and P2 is equal, which is 0.5 megapascal. So because of we know already it is saturated mixture and P is 0.5 megapascal, so we can find the T2. It is saturated mixture, so you just go through the table A5 because you are given with pressure. So you can find the T2 is equal to T saturated at 0.5 megapascal. It is equal to 151.83 degrees C. So this is question B. Okay, next we go to question C. In question C, you need to find the change in volume. So the change in volume. So it is equal to mV2 minus V1. Okay, so we look back at our state just now. So step 1, the info that we have is 0.5 megapascal. T is 200 degrees C and it is superheated. Okay, it is superheated. State 2, the pressure is 0.5 megapascal, and we have found the T2 just now, the T final, which is 151.83 degrees C. So it is saturated mixture. So we need to find the V2 and also V1. Okay, so we need to find the V1 and also V2. The V1 we can find directly because of we know it is superheated. We have P and also T, so we can just find at table A6, which is superheated. Okay, at table A6, so you can just directly get V is equal to 0.42503 cube per kg. But the problem is V2, it is saturated mixture. How to find the V2 for saturated mixture? We need to find through this equation, plus X VFG. Okay, so VF we can find, VFG also we can find because of we have P and we have also the phase, so we can find through table A5. But the problem is X. How can we determine the X? Okay, we look back at the question. It says that the mass, okay, one half of the mass condensed, so it means that 0.5 is vapor and another 0.5 is liquid, so it means that the X is 0.5. Okay, so because of that we can find V2 is equal to 0.001093 plus this 0.5 plus 0.37483 minus 0.001093, so you will get 0.1880 meter cube per kg. So now you have already V1 and also V2. You can just substitute in here. So lastly you will get negative 0.14222 meter cube. So we just take V2 from here, we substitute to here, V1 we substitute into here, and M is given, which is 0.6 kg, so you just direct calculate, so you will get this. Okay, so that question number 5. Next, question number 6. 1 kilogram of refrigerant 134A fills a 0.4 meter cube weighted piston cylinder device at a known temperature of negative 26 degrees C. The container is now being heated at constant pressure until the temperature has increased to 100 degrees C. Determine the final volume of refrigerant 134A inside the container. Alright, for this question, you need to find the final volume or V2, means V at state 2. Okay, clearly in the question it state we can see there are two states. Okay, state 1 and also state 2. 1 and also state 2 here. Okay, so we gather the info first. So for state 1, T is negative 26 degrees C, and the pressure don't know yet. Okay, we go to state 2. The T is 100 degrees C, and the P as well we don't know, but in the question it is stated constant pressure. Okay, constant pressure means that P1 is equal to P2, P2 is equal to P1. Just that we need to find the P first. Okay, so in order to find V2 here, we should have at least 2 info before we can get V2. But now we only have 1 info and the P is still not get yet. Okay, so our mission first is to find what is the P here. Okay, so we are given with another info, which is mass is 1 kg and the volume is 0.14 meter cube. So from here we can get the V1, isn't it? V1, specific volume, which is 0.14 meter cube over 1 kg, which is 0.14 meter cube. So this is V1. So from this V1, we already have two info, which is T1 and also V1. So from T1 and V1, we can get the P2. How? Okay, so I always mention to you, in order to find anything through property tables, we need to start with saturated table. Okay, this is refrigerant. Okay, this is refrigerant. So we need to find first at table A11. Okay, we need to find first at table 11, A11, sorry. Okay, so we use this info, and so this info we check at table A11. At table A11, okay, we look at temperature -26 and we check whether this V is between VF and VG or not. So when we check, we get already the V1 is between VG, V1 is between VG and also VF. So according to the first condition, it is saturated mixture. Okay, so because of it is saturated mixture, it is saturated. So from table A11, we just get the P is equal to P saturated. So the P saturated is 101.73 kilopascal. So we get already the, so means that we already get another info for state 2, which is the pressure, or 0.1 megapascal. So we need to find the V2, right? In order to find V2, we need to determine first the phase for state 2. Okay, so we look at temperature 100 degrees C at table A11. So we check whether this P is over or less than the P saturated. So when we check at table A11, we will get P is lower than P saturated, because the P saturated is 3975.1 kilopascal. So clearly this P is lower than P saturated. According to the first condition, when P is lower than P saturated, it is superheated. So once we know it is superheated vapor, we just go to the table superheated vapor for refrigerant. So you can just directly get the V2, but this is a specific volume, 0.30138. So in order to find the volume, so you need to multiply with the mass. So that's how you do question number 6. Next, question 7. 10 kg tetrafluoroethane is to be filled inside a rigid vessel with known volume of 0.5 meter cube. After temperature measurement is done, it is found that the temperature of tetrafluoroethane in the vessel is -20 degrees C. Determine A. The pressure of tetrafluoroethane inside the vessel, B. The quality and total internal energy of tetrafluoroethane inside the vessel, C. The mass and volume of liquid portion inside the vessel. Okay, so to understand this question, we have a rigid vessel. Okay, so we have a rigid vessel. So we are going to fill this rigid vessel with the tetrafluoroethane. Okay, 1348, which is refrigerant. It is refrigerant. We want to fill refrigerant inside this rigid tank. So after we have filled inside this rigid tank, so we measure the temperature, which is 20 degrees C. Okay, so it is filled with 10 kg of refrigerant and also 0.5 meter cube. Okay, question A. We need to find the pressure of refrigerant inside the vessel. Okay, so the info that we have is T negative 20 degrees C. So we need to find the pressure. So in order to find the pressure, we need at least two info. First is temperature, and we have to find another one info so that we can find what is the temperature. Okay, so we look back at the question. So we have 10 kg and also 0.5 meter cube refrigerant. So means that we can calculate the specific volume, which is 0.5 meter cube over 10 kg, which is 0.05 meter cube per kg. So now we have two info, T1 and also V1, so we can find the P1 from the table. This is refrigerant, right? So we can find the pressure from the table A11. So we look at table A11. So we check at negative 20 degrees C, and we check whether this V1 is between VF and VG or not. So after we check at table A11, so we have found that this V1 is between VG and also VF. So according to the phase condition, when it is between, so the phase is saturated mixture. So when it is saturated, so we can just directly get the pressure here. So P1 now we can just get from the P saturated, which is 132.8 kilo Pascal. Okay, that's question A. Next, question B. So we need to find the quality and also total internal energy, which is U. We have to find X and also U. So how can we find X? So we know already, just now we have found that the phase of refrigerant inside this rigid tank is saturated mixture. So when it is saturated mixture, yes, of course we need to find X. So the problem is how to find the X. Okay, just now we have found that the V1 is equal to 0.05 meter cube per kg. So in order to find X, we need to remember this equation. V1 is equal to VF plus X VFG. When we talk about saturated mixture, of course we need to use this equation. So how to find X? We can find X from here. X is equal to V1 minus VF over VFG. So V1 we already have V1, VF and also VFG we can get from table A11. So X is equal to 0.05 minus 0.000732 over 0.14729 minus 0.00073 0.362 and you will get 0.3361. So this is the quality. Right, how about U? So we need to find U, right? So U, because of this is saturated mixture, we need to use this equation as well. UF plus X UFG. So X we already get here. This is the X, so just substitute in here. So you will get U is equal to the UF and also UFG you can get from table A11 as well. So UF is 25.39 plus 0.3361, okay, multiply with UFG, which is 193.45. So you will get 904.2 kilojoule. That's how we find the X, the quality, and also the total internal energy inside the vessel. Okay, next question C. So we need to find mass and also volume of the liquid portion inside the vessel. So it means that we need to find M liquid and also V liquid. Okay, so how to find the M liquid? Just now we have found X, which is 0.3361, and we know that X, it has relation with M, but M vapor and also M liquid. So how? So the original equation for X is M vapor over M total. So because of this is fraction, we can do like this: 1 minus X is equal to M liquid over M total. So we can use this equation to find the M liquid. So to find M liquid, 1 minus 0.3361 is equal to M liquid over the M total is 10 kg. 10. So M liquid is equal to 6.639 kg. So that's how we find the M liquid. For V liquid, if you still remember question number 3, V liquid we can find through M liquid over VF. Okay, so M liquid is 6.639 and VF we can get from table A11, which is 0.000732. So we will get 0.00489 meter cube. So this VF we get from table A11 at T negative 20 degrees C. Okay, so that's how we do question number 7. The last question, question number 8. 100 kg of tetrafluoroethane at 200 kilopascal are contained in a piston cylinder device whose volume is 12.322 meter cube. The piston is now moved at constant pressure until the volume is 1/2 its original size. Determine the final temperature and the change in total energy of the substance. Alright, according to this question, the piston is moving. So when the piston is moving, yes, of course, we have state 1 and also state 2. So we get the info. State 1 we have P1 is 200 kilopascal, and because of it is constant pressure, so the P2 as well is 200 kilopascal. So in order to find the final temperature, which is T2, we should at least have 2 info here so that we can get the final temperature here. So what is the info that we can get? Okay, so we look back at the question. It says that the piston is now moved at constant pressure until the volume is 1/2 of its original. So means that V2 is 1/2 of its original, means that its original volume is V1. So V2 is V1 divided by 2, it is 1/2. So in order to find T2, we need to find first the V2 so that we have two info. So in order to find V2 here, we need to find first the V1. So how to find the V1? So we look at the question. You are given with M is 100 kg and volume is 12.322 meter cube. So V1 we can get from V over M is equal to 12.322 meter cube over 100 kg. So it is equal to 0.12322 meter cube per kg. So now we can have another info for state 2, which is 0.12322 over 2, it is equal to 0.06161 meter cube per kg. So because of we have already two info, P and also V, so we can find the T2. But before that, we have to determine first the phase. So after we check from table A12, so we found that the V2 is between VF and also VG. So it means that the phase is saturated mixture. So once we know it is saturated mixture, so we can just use the T saturated. So T2 is equal to T saturated. It is equal to negative 10.09 degrees C. So that's how we get the final temperature. Next, we need to find the change in total internal energy of the substance. So in order to find the total internal energy of the substance, we need to find through delta U is equal to U2 minus U1. So means that we need to find the U1 and also the U2 here. Okay, so we need to find the U1 and also the U2. Okay, first we look at state 1 to find the U1. We have to determine first the phase. So what is the phase? So we check at table A12 at 200 kilopascal. So we check this V1, it is between VF and VG or not. So after we checked, we found that the V1 is higher than VG. So means that it is superheated. So once it is superheated, we go to table A13. So we can directly get the U1, which is 263.08 joule per kg. Okay, now in order to solve this, we need to find U2. So how to find U2? So because of this is saturated mixture, we need to use this equation, which is U2 is equal to UF plus X UFG. But the problem is we need to find the X. So how to find the X? Look at here, we have V2. Okay, so in order to find X, we can use this V2. How? So V2 is equal to VF plus X VFG. So when we rearrange, X is equal to V2 minus VF over VFG. So The VF and also VFG we can find from table A12. So V2 here is 0.6161 minus 0.007533, sorry, not 0, over 0.099867 minus 0.0007533. So X, you will get 0.6135. So we already get X, so now we can substitute in here X in order to find U2. So UF and also UFG you can find from table A12. Okay, so UF is 38.28 plus X is 0.6135 and UFG is 106.25. So we will get the answer for U2 is 152.52 kilojoule per kg. So now we want to solve this, the change in total energy of substance. So now we have already U1 and we have already U2. So you just substitute U1, you substitute in here, U2 you substitute in here. So you solve, then you will get negative 110.6 kilojoule per kg. Right, so that is how we solve question number 8. So this is the last question. I hope you can understand, and if you have any question you can ask me through forum or through Microsoft Teams. Okay, till we meet again in another video. Assalamualaikum.